Let's use what we've learned about reference angles and special trig values to find the exact value of the cosine of the angle -5 pi over 4. It might be helpful to take our angle here in radian measure and express it in degrees. So keep in mind that -5 pi over 4 is really just -5 multiplied by pi over 4, which is equivalent to 45 degrees. So this guy is just -225 degrees. So if I want to sketch this angle here, I can start on my coordinate plane. I'm going to rotate clockwise in the negative direction to the second quadrant, where I can locate my terminal side on the angle -225 degrees. In this case, I observe that my reference angle is 45 degrees, and I can go ahead and sketch a right triangle here in the second quadrant. And using some of the values that we've talked about up till now, I can designate this radial length, or the hypotenuse of my right triangle, as √2. My legs then would be 1. This is my 45, 45, 90 right triangle. And that would make my point on the terminal side of this angle -1, 1. So I go left 1 and up 1 to get to that value. From here, I can go ahead and evaluate the cosine of -5 pi over 4, as recall that the cosine value is always x over r, which in this case is just -1 divided by the square root of 2. So we've used what we know about reference angles to create what we call a reference triangle on the coordinate plane. And we're able to evaluate the cosine of this angle using our definition of a point on the terminal side. Let's do another example. All right, here we'd like to evaluate the exact value of the cosine of 7 pi over 6. Again, I can look at this in, if it's helpful, convert it to degrees. So 7 multiplied by pi over 6 is the same thing as 7 multiplied by 30 degrees, or 210 degrees. I can sketch this angle on my coordinate plane by rotating counterclockwise into the third quadrant. And in fact, my reference angle in this case will be 30 degrees because I've rotated 30 degrees past my 180 degree mark. And I can again use one of our special right triangles here. I have an angle of 30 degrees. If I let my hypotenuse be 2, I know the side opposite 30 degrees will be 1. And the Pythagorean theorem tells me that the third side here is the square root of 3. The point on the terminal side of my angle, in this case, would be -√3, -1. I'm going to the left and down to get to that point. It's in the third quadrant. And therefore, I can evaluate the cosine of 7 pi over 6 as x over our radial length r, which in this case is -√3 over 2.